In this video today, we're going to talk about absolute value inequalities. In a previous video, we talked about absolute values and absolute value equations, kind of similar. So let's take a look at our first inequality. The absolute value of 3x is less than or equal to 9. Now, when it came to absolute value equations, we had to split it into a positive case and a negative case. We're going to do that here. So we got 3x is less than or equal to 9. But we're going to get 3x is greater than or equal to negative 9. Now this reason is kind of the same reason as making the signs flip when we multiply or divide by a negative. It's kind of related because we did make a negative 9. So let's solve the positive case first. We're going to divide both sides by 3. We're going to get that x is less than or equal to 3. Graphing it will be a solid dot at 3 and all numbers to the left. Now in the negative case, we'll do the same thing, but this time we get that x is greater than or equal to negative 3. Graphing it at negative 3 with a solid dot, all numbers to the right. Notice that there's a big overlap here. Okay, because of that overlap, we're going to use and. We're going to say that x is greater than or equal to negative 3 and x is less than or equal to 3. We can rewrite this as such. Negative 3 is less than or equal to x is less than or equal to 3. Now, for all the solutions that work here, it's just this range from negative 3 to positive 3. This is called an intersection, and an intersection is represented essentially with a upside down capital U. So what is it? It's an overlap of two sets, in this case, two inequalities. It's elements that apply to both, and only both. So let's take a look at another example here. X is less than 5. So these numbers are like 4, 0, negative 10, etc. And we have x is greater than or negative 5. So these numbers would include negative 4, 3, 9, and so on. All right. Now, if we look at the intersection of these two inequalities, they only include numbers between negative 5 and 5. However, negative 5 and 5 are not solutions because there's no equal to on either one. So 5 is only in one of the solutions and negative 5 is in the other, but neither of them are in both. All right, let's take a look at another example. The absolute value of x minus 2 is greater than 10. Once again, we're going to have to separate it into two inequalities. We're going to do the x minus 2 is greater than 10, so essentially the same thing without the absolute values. And we're going to look at the negative case. So we're going to flip that sign to give us x minus 2 is less than negative 10. All right, now we're just going to solve the two inequalities and graph each of the solutions. So I'm going to add 2 to both sides, which gives me x is greater than 12. So when I graph it, I'm using an open circle because 12 is not included. All right, so next I'm going to add 2 to both sides here. That's going to give me x is less than negative 8. Once again, same thing. This time it's at negative 8 and it's going to the right. Now, since there is no overlap, we're going to say that x is less than negative 8 or x is greater than 12. This is called a union. Now, a union can be all elements from the sets. The elements of one set, the elements of a second, and any overlap are considered part of the union. And we'll take a look at another example here soon. But let's use that same inequality from the previous example. Same numbers, same inequalities. Now, if we take the union of these two, it's technically all real numbers. And we'll take a look at that in just a moment. Okay, visually, from our two examples previously, the intersection is where these two lines overlap, like so. So from -5 to +5. Now, if we look at the union, that's technically all those numbers because it's the numbers from one set, the numbers from the second set, and where they overlap. So nothing is taken out here. And since both go in opposite directions for infinity, it's including all real numbers. Now, I want you to take a moment and solve this one yourself. Pause the video and go ahead and give it a try. Okay, welcome back. Now, here is the solution to this problem. Check your work. Did you get it all right? If you did, awesome. You did a great job. If not, take a look at the video again and see where you went wrong. I hope you enjoyed this video.